So let's go do another example here of another transducer. So a reminder, that's just a Turing machine that does not accept or reject. It takes the input and it produces output. That output is left on the tape. So what I was thinking as a fun little idea is we're going to try to capitalize letters. So I want you to suppose that we're given a finite string of lowercase alphabetical letters. So for example, somebody gives you the word cat like this, no spaces. But it's worth noting that it won't be very hard to take our Turing machine and modify it so it has this ability. I'll leave that for you to think about. Or other words like spot, and maybe auto, turtle. So as input, we are given a string of lowercase English letters. Of lowercase English letters. So what I would like to do is I would like to output a string of the same symbols except capitalize. Except capitalized. So for example here, if I want cat, I want it to be capital C, capital A, capital T. For spot, I want it S-P-O-T, all capital letters. And turtle, I want it to be T-U-T-L-E. So a lot of programming languages will have something like this, some sort of thing that's like to upper or something of that sort. So I'm going to show you how you can come up with a transducer that does something like this. So believe it or not, I've shown you actually a really basic example in an earlier case where we swept from left to right, replacing letters with another letter. What we could do is something very much like this, where we scan from left to right across the tape, starting at the first symbol of the input. And whenever you encounter a lowercase letter, you're going to stay in the same state, but you're going to scan one symbol to the left after you have replaced the lowercase letter with its uppercase counterpart. And that's actually all you need to do. So for example, if you imagine you have your tape like this. Remember, there's blanks on all around here after. So if I have a cat, for example, if the tape's here, I would like it to just replace, like right on the tape, capital C instead. Move the tape one left, sorry, not left, right. Uppercase A, move it to the right, uppercase T. And when do we stop doing this? When you see the blank. But now, I need to be a bit careful here because remember, what we usually use is as a blank symbol is capital B. So what I'm going to do now is I'm going to use a different symbol just to illustrate that you can use a different symbol. So I'm going to define our Turing machine. So here we go. So let the transducer TM TL be equal to the following. It's going to have two states. We're going to call them QR and QF. Its input symbols are going to be lowercase English letters. Its tape symbols, remember, now this is where the thing you have to keep in mind is that the tape symbols include the input symbols. So you have to put all of those in there too. A, B, C, all the way up to Z. Uppercase A, uppercase B, dot, 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 all the way uppercase Z. And then we're going to need a blank symbol. Now, in my notes, it's easy enough to see the difference between the type-faced B or an alphabetical B versus a fancy B. So I'm going to instead use a big box that looks like this, just to make it a little bit clearer that it's a blank. Next, I have to give you the transition function. The final state, the start state is QR. Remember, that's the start state. Remember, we don't have final states, right? And the blank symbol is this box. It's technically a rectangle, but I'll leave that here, there, and there about the debate of whether boxes are rectangles and squares and rectangles are the same thing. That is not what we're going to discuss here. So, let's now define how this will work. So we have an idea already here, which this is nice, where delta is defined by the below transition table. So we're going to use a transition table. Now this table is going to be a little bit kind of clunky to look at, just because it has a lot of columns. So I'm going to omit a whole bunch of the columns just for the sake of brevity. So it's going to have two states, QR and QF. It's going to have A, B, dot, dot, dot. Z, lowercase z, to be a bit more precise. Uppercase A, dot, dot, dot. Uppercase Z, blank symbol. So those are the columns of our transition table. You might ask, Dan, why have so many columns? Since remember, each of the columns, there has to be a column for each one of the tape symbols. So keep that in mind. It's really important to remember that. So you might ask why I put all these dots in here. It's because I'm going to represent the table by truncating the rows and columns appropriately. So if I could describe it carefully enough, I don't have to write every one of the rows, every one of the columns. There's a lot of columns here. So remember, the whole idea is if I see a lowercase a, I want to put it as an uppercase A, right? So I want to continue to read. So I'm going to call this QR because I want to think of this as read, and F to be when I'm done, when I'm finished. So I want to imagine I'm reading the words. So I replace the lowercase a with a capital A, and then I move right one, like I did here in our example. I'll do the same thing with the lowercase b. So I stay in QR. I replace with a capital B, then I move right. I'll do this for the C, D, E with their corresponding uppercase letters. Lowercase z, we're going to replace that with an uppercase Z. It's kind of hard to tell that they're lower or upper, but my hope is that you'll get the impression by how tall it is. It's the big boy of Zs, okay? But notice that A, we don't read any uppercase letters, so these are all really easy for me to describe. It's just undefined. But when I see the blank, that's when I know I'm done reading. So I switch over to QF. I leave the blank as a blank. Now, I don't want to use a B here because the symbol is now this symbol here. So I'll go right. And now QF's really easy because this is a final, well, it's not technically a final state, but I'm using it to halt the machine. So all of these in the second row don't have any moves defined. Whoops, I need dot, dot, dot. Because I want it to halt. Now, believe it or not, there's actually an alternative way of formally defining this using actually the formal description of the transition function, which arguably looks a little nicer than this if you define a function that takes each lowercase letter and outputs the uppercase letter. I'll leave that in my notes if you're curious about this afterward. So this is how you can come up with a Turing machine for which it will take lowercase letters and it converts them to uppercase letters. This one adapts a very simple strategy of just going from left to right.